Hello and welcome to BrushMyQuant channel. Today we'll talk about basics of statistics. We'll go through what is a mean and couple of properties of mean, median and properties of median. We'll see what is a range and properties of range. We'll go through mode, weighted mean, variance and properties of variance, standard deviation and properties of standard deviation. Let's start by going through the mean. So mean or average or arithmetic mean of a set is the sum of all the elements in the set divided by total number of elements in the set. Let's take an example. So let's say we have a set of 5 elements, A1 to A5. Then we can find the mean by first finding the sum, which is nothing but sum of A1 to A5. And the mean will be nothing but sum of all the values divided by total number of values, which is 5 in this case. So mean of any set is nothing but sum of all the elements in the set divided by total number of elements in the set. Let's take some examples. So let's try this problem. Find the mean of the following sets. So the first set given to us is 1, 2, 3, 4, 5. And we need to find the mean of this set. So to find the mean, we will first find out the sum of all the elements, which is nothing but 1 plus 2 plus 3 plus 4 plus 5 divided by total number of elements, which is 5. So mean will be nothing but sum of all these elements, which is 15 divided by 5, which is nothing but 3. Let's try the second one. So the set given to us is 2 minus 3, 4 minus 7, 0 and 8. So the mean will be nothing but 2 plus minus 3 plus 4 plus minus 7 plus 0 plus 8 divided by total number of elements. So we have 6 elements here. So we'll divide by 6. So which is nothing but minus 1 plus 3 minus 4 and plus 4 divided by 6, which is nothing but 2 by 3. Let's try more problems. So the problem is find the mean of below set. Now a set of values are given to us and they are asking us what is the mean of all these values. So on the x-axis we have scores and on the y-axis we have students. So let's see how we can read this bar graph first. So I have a score of 10 which is scored by 5 students. I have a score of 20 which is scored by 4 students and so on. And I have a score of 90 scored by 4 students and 100 by 5 students. And we need to find the mean of this set. So if you look at this set is actually quite symmetric. The numbers are going down and then the numbers are going up. So if you look from the center, the same number of elements are towards the left and towards the right and are also equidistant from the center. So if you consider 50 and 60 as the center, we can very well say that the mean will be somewhere between 50 and 60 because the entire bar graph is symmetric as compared to 50 and 60. And we can very well say that the mean is actually 50 plus 60 by 2, which is nothing but 55. And we can say this only because this is a symmetric set. So whenever you get a question where you have symmetric sets, you don't need to calculate the mean. You can directly say the mean of the set will be nothing but the center of the set, which in this case is also equal to 10 plus 100 by 2, which is nothing but 55. We'll talk about this bit more in the video for sequences. I will put the link of sequences in the description. So please go through it and this concept will be more clear to you. Now let's talk about some of the properties of mean. So if all the numbers in the set are increased or decreased by the same number, then the mean also gets increased or decreased by the same number. Let's take an example. So let's say the set given to us is 1, 2, 3, 4, 5. And we already know that the mean of this set is 3. Now let's go and add 2 to all the numbers. So the new set becomes 3, 4, 5, 6, 7. Let's try to find out the mean of this set, which is nothing but sum of all the values divided by total number of values, which is 7 plus 5, 12, 12 plus 6, 18, and 18 plus 7, 25 by 5, which is nothing but 5. So what happened in this case? We increased all the elements by 2, and even the mean got increased by 2. So remember the property, if all the numbers in the set are increased or decreased by the same number, then the mean also gets increased or decreased by the same number. Now let's see what happens if we try to multiply or divide all the numbers in the set by the same number. So if all the numbers in the set are multiplied or divided by the same number, then the mean also gets multiplied or divided by the same number. Let's take an example. Let's take the same set, 1, 2, 3, 4, 5. We know the mean is 3. Now let's multiply all the numbers by 2. So the new set becomes 2, 4, 6, 8, 10. Let's try to find out the mean of this set. So this becomes sum of all the numbers divided by total number of numbers, which is 6 plus 6, 12, 12 plus 8, 20, 20 plus 10 is 30, divided by 5, which is nothing but 6. So we multiplied all the numbers in the set by 2, and even the mean got multiplied by 2. Now let's go ahead and talk about the median. So median of a set is nothing but the middle number of the set, or the mid value of the set. Now let's take two cases. In the first case, we have odd number of elements in the set. So if the set has odd number of elements, first of all, we'll go ahead and arrange the set in ascending or descending order. Then the median is nothing but the middle element of the set. Let's take an example. So let's say the set given to us is 5, 1, 2, 4, 3. So we'll go ahead and arrange it in ascending order first, so which is nothing but 1, 2, 3, 4, 5. And since we have odd number of elements, so the median will be nothing but the middle value, which is the third value. And how do we find the middle value? It is nothing but the number of terms, which is 5, plus 1 divided by 2, or nothing but the third term. Now let's see what happens if we have even number of elements in the set. So if we have even number of elements in the set, then again we'll go ahead and arrange the set in ascending or descending order. And the median is nothing but mean of middle two values of the set. So let's take an example. So let's say the set is 1, 2, 3, 4, 5, 6. Since we have even number of values, which is nothing but 6 values in this case, so the median will be nothing but mean of middle two values. So 3 plus 4 by 2, or nothing but 3.5. Now you might be thinking, how do I find the middle two values? So which two values should I consider? So the formula for that is, if the number of elements in the set is n, then the middle two values will be given by n by 2 and n by 2 plus 1th term. So let's apply that in this case. So we have n as 6. So that means the middle two terms will be 6 by 2th term and 6 by 2 plus 1th term, which is nothing but 3rd and 4th term. Let's try out some examples. So find the median of the following sets. The first set is 1, 2, 3, 4, 5. So they have already arranged in ascending order. And we know that the set has odd number of values or 5 values. So the median will be nothing but 5 plus 1 by 2th term, or nothing but the third term, which is 3 in this case. Let's try the second one. So the set is 2 minus 3, 4 minus 7, 0 and 8. So let's arrange it in ascending order first. So we'll get minus 7, minus 3, 0, 2, 4, and 8. Now here the set has even number of values. So the median will be given by mean of middle two numbers. So the middle two numbers can be found by 6 by 2th term and 6 by 2 plus 1th term, which is nothing but the mean of third and fourth term, which is this and this in this case. So the median is nothing but the mean of 0 and 2, which is 1. Let's try more problems. So the question is, find the median of below data set of 100 values. Now a frequency distribution table is given to us and they are asking what is the median of this data set. Now the good thing is this is already arranged in ascending order. And we know that the data set has even number of values. So the median will be given by mean of middle two values, which is nothing but 100 by 2th term and 100 by 2 plus 1th term, or the mean of 50th term and 51st term. So we'll start from the top and we'll see when exactly do we reach the 50th and the 51st term. So 2 plus 5 is 7. 7 plus 42 is 49. So we know that our 50th and 51st term lie in this range of 60 to 90. That means the median of this data set will be between 60 to 90. Now let's go through some properties of median. So in case of arithmetic sequence or evenly spaced sequence, in that case, if you have odd number of terms, then your mean and median will be same and they will be equal to the middle term. Let's take an example. So let's say the set is 1, 2, 3, 4, 5. And we already know that the mean and the median of this set are 3, which is also equal to the middle term of the set. And in case of arithmetic sequence with even number of terms, mean and median will again be the same and will be equal to mean of middle two terms. Let's take an example. So 1, 2, 3, 4, 5, 6 is the set, which is an arithmetic sequence because the numbers are evenly spaced, and the mean and the median will be nothing but the mean of middle two terms, which is 3 plus 4 by 2 or 3.5. Let's see more properties. So in case of consecutive integers, if the number of terms is even, then mean is equal to median, but is not equal to an integer. So let's take the same example of 1, 2, 3, 4, 5, 6, where we have 6 consecutive numbers. And what we are saying is the mean and the median are same, which is 3.5 in this case, and this will not be an integer. So remember this, in case of consecutive integers, if the number of terms are even, then mean and median will be same, but it will not be an integer value. Let's see more properties. So if all the numbers in the set are increased or decreased by the same number, then the median also gets increased or decreased by the same number. Let's take an example. So the set is 1, 2, 3, 4, 5. Let's increase all the elements by 2 to have the set as 3, 4, 5, 6, 7. Now the median of this set is 3 and this set is 5. So we added 2 to all the numbers and even the median got increased by 2. If you remember, mean also had the same property. Let's see what happens when we do multiplication and division. So if all the elements in the set are multiplied or divided by the same number, then the median also gets multiplied or divided by the same number. This is exactly same as what we did in case of mean. So mean and median follow the same property. So all the elements in this set are multiplied by 2 and even the median got multiplied by 2. Let's talk about range now. So range of a set is the difference between the highest and the lowest element of the set. So if they have given you a set, first of all, we are going to arrange the set in ascending or descending order. Then we are going to find the lowest value and the highest value. And the range is nothing but highest value minus lowest value. Let's take an example. So find the range of the set 13579. Now they have already arranged the set in ascending order. So we can directly make out that 1 is the minimum value and 9 is the maximum value. So range is nothing but the maximum value minus the minimum value, which is 9 minus 1, which is nothing but 8. Let's see some properties of range now. So if all the elements in a set are increased or decreased by the same number, then the range does not change. Let's take an example. So let's say the set is 1, 2, 3, 4, 5, and the range becomes 5 minus 1 or nothing but 4. Let's increase all the numbers by 2 to have the new numbers as 3, 4, 5, 6, 7. So the range becomes 7 minus 3, which is nothing but 4. So the range did not change. And why is that? Because we got 7 by adding 2 to 5 and 3 by adding 2 to 1. And when we are finding the range, we are subtracting the highest and the lowest value. So if you simplify this, it becomes 5 minus 1 plus 2 minus 2. So whatever increment we did on both the numbers, we are essentially subtracting them. So it is cancelling out and our range remains the same. Now let's see what happens when we try to multiply or divide by the same number. So if we have the same set 1, 2, 3, 4, 5, and if we multiply all the numbers by 2 to get the set as 2, 4, 6, 8, 10, then the range becomes 10 minus 2, which is nothing but 8, which is nothing but 2 multiplied by 4. Now what happened in this case? We got 10 by multiplying 5 by 2 and 2 by multiplying 1 by 2. We can take 2 common and it becomes 2 times 5 minus 1 or 2 multiplied by 4 or nothing but 8. So if all the numbers in the set are increased or decreased by the same number, then the range does not change. But if all the numbers in the set are multiplied or divided by the same number, then the range also gets multiplied or divided by the same number. Let's talk about mode now. So mode of a set is the element which has occurred the maximum number of times. Let's take an example. So find the mode of the set 3 times 1, 2 times 2, 4 times 3, and 4, 5, and 6 each are 1 time. So that means mode of this set is 3 because 3 has occurred the maximum number of times. Let's take a different example. So if the set was 1, 1, 2, 2, 3, 4, in this case, the set will have two modes, 1 and 2, because both of them have occurred the maximum number of times, which is 2 in this case. Let's talk about weighted average now. So weighted average is nothing but sum product of weight and value divided by sum of all the weights. This is a very common thing used in calculating school GPAs or your college GPAs. Let's take an example. So if an employee's performance consists of 20% of component A, 30% of component B, and 50% of component C, and if he receives 10 in A, 20 in B, and 10 in C, then find the overall performance of the employee. So we have three things or three components against which our employee's performance is being graded: component A, component B, and component C. And all of them have been given some weight. And the employee has scored some points in component A, some in B, and some in C. And we need to find the overall performance of the employee. So we are going to use weighted average formula in this, which is nothing but weight in component A, which is 20%, multiplied by value in A, which is 10, plus weight in B, which is 30%, multiplied by value in B, which is 20, plus weight in C, multiplied by value in C, divided by sum of all the weights. So 20% plus 30% plus 50%, which is nothing but 2 plus 6 plus 5 divided by 1, or nothing but 13. So you will notice that even though the employee scored 20 in B, then also his score is only 13. This is because your B component has only 30% weight, but the C component had 50% weight, and in that the employee scored only 10. So definitely his final score is going to be closer to 10 as compared to 20. Let's talk about variance now. So variance is nothing but mean of square of difference of each number from the mean. That means variance is nothing but the sum of square of difference of each number from the mean divided by total number of numbers. And we are going to calculate variance because this is going to be used in the calculation of standard deviation. So let's take an example. Find the variance of the set 1, 2, 3, 4, 5. Now we already know that the mean is 3. So the variance will be given by subtracting all of these values from the mean and taking a square of it and adding them up. So we are going to take each and every value. We are going to subtract it from the mean, which is 3, square it up, and sum all of those values. So let's do it for all the 5 values in this set. And since it is the mean, so we are going to divide it by the total number of values, which is 5 in this case. So this becomes 2 square, which is 4, plus 1 square, which is 1. This is 0, minus 1 square, which is 1, and minus 2 square, which is 4, divided by 5, which is nothing but 10 by 5, or 2. Now let's talk about some of the properties of variance. So if all the numbers in the set are increased or decreased by the same number, then the variance does not change. Let's take an example. So let's take the first set as 1, 2, 3, 4, 5. We know the variance is 2. Let's add 2 to all the values to get the set as 3, 4, 5, 6, 7. Now we know the mean is 5. Let's try to find the variance. So we are going to subtract all the values by 5 and square them up and take a mean of the same. Plus 5 minus 7 whole square divided by 5, which is 4 plus 1 plus 0 plus 1 plus 4, which is 5, which is same as 2. Now why did this happen? Because this is very similar to what we used to do in range. Because we are subtracting all the values from the mean. So whatever increment which has happened in all the values, the same increment happened in the mean. So when you're trying to subtract the values from the mean, the change which we did is actually cancelling out. So the variance remains the same. Now let's see what happens when we try to multiply or divide by the same number. Let's multiply by 2 to have the set as 2, 4, 6, 8, 10. That means the mean is 6. Now we are going to do the calculation for variance. So let me quickly go ahead and do that. And let's divide it by 5. And we are going to have 4 square, which is 16, plus 2 square, which is 4, 0, 4 and 16 divided by 5, which is nothing but 40 divided by 5 or nothing but 8, which can also be written as 2 multiplied by 2 square. So if all the numbers in the set are multiplied or divided by the same number, then the variance gets multiplied or divided by the square of the number. Since we multiplied all the numbers by 2, so the variance got multiplied by 2 square. Now let's talk about standard deviation. So standard deviation, also called as SD, is an indication of how spread the values are as compared to the mean. That means in a set, if all the values are very close to the mean, the standard deviation is going to be very less as compared to the set where the values are far away from the mean. So standard deviation is equal to root mean square of the distance of the values from the mean. That means standard deviation is actually equal to square root of variance. Let's try it out. So find the standard deviation of the set 1, 2, 3, 4, 5. Now we already calculated the variance of this set and we know that the variance of this set is 2. That means the standard deviation of this set will be square root of variance, which is square root of. Now you might be thinking that in that case the standard deviation should always be a positive number. But standard deviation can very well be 0. Let's take an example. So standard deviation of one element set is always equal to 0. And why is that? Because the mean of this set will be nothing but the element itself. So let's say the element is 3. So mean will be 3 and the variance will be nothing but 3 minus 3 whole square divided by 1, which is 0. So your standard deviation will also become 0. Standard deviation of a set with all numbers equal will also be equal to 0. Let's take an example. So let's say we have a set with 3 values which are all 2. So the mean will be 2 and the variance will become 0. Because distance of all the numbers from the mean will be 0. So standard deviation will also be equal to 0. Now let's see some of the properties of standard deviation. So if all the numbers in a set are increased or decreased by the same number, then the standard deviation does not change. This property is same as variance. Since the variance does not change in this case, and standard deviation being square root of variance will also not change. Now if all the elements in a set are multiplied or divided by the same number, then the standard deviation also gets multiplied or divided by the same number. Now if you remember, the variance was getting multiplied by square of this number, and standard deviation is square root of variance will become nothing but square root of variance into k square or square root of variance into k, which is nothing but standard deviation into k. So if all the numbers in a set are multiplied or divided by the same number, then the standard deviation also gets multiplied or divided by the same number. Let's try out some problems on standard deviation now. So which of the following sets has higher standard deviation? So 3 sets are given to us. The first one is an arithmetic sequence because the numbers are equally spaced. So is the second one. The third set also looks symmetric, but we have one very big value. Now, if you remember, I told you standard deviation is an indication of how far the numbers are as compared to the mean. If you look at this set, the numbers are actually quite close to the mean. The same is in the second case. But in the third case, you have a very big number. And all other numbers are actually closer to the mean. So the third set will actually have a higher standard deviation because the values are more spread from the mean as compared to other sets. Let's try more problems. So will the two sets shown below have same standard deviation? So let's look at the sets. So the scores are given to us and the frequency. And in this case also some scores are given to us and the frequency. So both the sets are actually looking symmetric as compared to the mean. And from the mean, they have the same distance also. So if you look at the two sets, in this case, actually the mean will be 55. And in this case, the mean will be 135. And all the values are actually looking symmetric as compared to the mean. They are actually symmetric as compared to the mean in both the cases. And the distance is also same. So that means these two sets will have the same standard deviation. Now let's go ahead and do a quick recap of the different properties we learned today. So if all the numbers in the set are increased, decreased, multiplied or divided by the same number, then the mean and the median will get increased, decreased, multiplied and divided by the same number. In case of addition and subtraction, the range does not change. But in case of multiplication and division, the range also gets multiplied or divided by the same number. In case of addition and subtraction, the variance does not change. But in case of multiplication and division, variance gets multiplied or divided by the square of that number. And standard deviation also does not change in case of addition and subtraction. But in case of multiplication and division, standard deviation also gets multiplied or divided by the same number. I hope you were able to understand the basics of statistics and the different properties of them. If you did, please go ahead and like the video, subscribe to this channel and provide your valuable comments, and do share this video with your friends. Thank you.